Hey everyone, this is Richard from Team Guardian. In this video, I'm just going to go over a quick rundown of how the guidance script or the guidance system actually works. Just give you a quick overview to refresh your memory here. So I'm on guidance2.py, and the main function that's running here is mission runner. So this runs through a list of mission modules in the mission. So mission modules are things like waypoints, search patterns, drop locations, that kind of thing. And we can create new mission modules to add functionality. And then we chain a bunch of mission modules together to create a full mission. And then think of this as a playlist of things that the drone is going to go do, things it's going to go run. So mission runner runs through the list of mission modules. And what it's doing is looking for the mission state, which tells us when we're actually done the full mission. So we've run through all the modules, and it's also looking for whether the mission module is done or not. So there are two states we can have here. So this is mission module return.complete. This is the same as an enum in C. So this is saying that the particular module we were running is done. So if it was a waypoint, this will run when we actually reach that waypoint, or this will be true when we reach that waypoint. Mission module continue location updated is for modules that contain multiple locations inside them. So that is something like a search pattern, which consists of a bunch of waypoints that we need to go hit. And this is saying we've reached, for example, waypoint 1 in the in that mission module, in that search pattern, and we're going to go continue to waypoint 2 in that search pattern. And next we can go into the goto function. So this takes the current mission module, and right now it just runs the simple goto command, since we only have locations, and then it's just going to pause for half a second. Then we check if we have reached the location correctly. If not, we keep going. If we do reach it, so if we're very close, we run the reached function of each module. So now we can get into how mission modules are actually constructed. So we'll go into mission module.py. So this is the base class, is called the waypoint class. So this is the most simple mission module. And you can see it's got a few arguments in the constructor. So the latitude, longitude, and altitude, as well as the pause time, which is how long the drone will hover at this location once it gets there. It has the location associated with it and the pause time. So these are just the internal variables here. And then every mission module has to have a reached function. So this says what the drone will do when it actually hits that location. So you can see we run this in goto when we've gotten very close to the target location. We run this function. So this could do something like, in the case of a drop location, in the reached function, we would actually drop the water bottle. Typically, though, it will just say we have reached the location. It will print that out, and then we need to set mission module return.complete to say that we are done running that particular module, and then we'll go on to the next one. Now we can look at the mission, how the missions are constructed. So this is in mission.py. So we have one important enum here is the mission state. So this is saying we've either not started the mission, we are currently running the mission, or we've completed the mission. So a mission is composed of a list of mission modules, which is the entire mission. it is also composed of the current mission module that we're running, and then we have the current number of the module that we're running, and then the total number mission state as well. So when we create a new mission, we run create mission. So right now, thanks to work from Harry, this is looking at the setmission.csv file and is pulling in all of the mission data that we define here. So here we are defining that we want a mission with 2 waypoints, then a search pattern, and then another waypoint. And these numbers here are the coordinates associated with each of these modules. And we'll run through these in order. And mission.py will add these to the current mission. And then we have various functions for adding and deleting modules from the list, going to the next module, which is what happens when we actually complete the current module that we're running. So again, it's really just a playlist of modules. Each module has a location or multiple locations associated with it, and a function that will be run when the locations are reached. And we just play through all of those. The additions that we'll have in the future are, instead of using simple goto, we will be using velocity vector control to be able to change our direction as we are on the way to a particular location. Right now this just goes in a straight line, but we need the ability to change our path to avoid obstacles as we're going from point A to point B. We will also have integration with the AVSI interop system, which is the server they give us that sends us the waypoints and locations that they want us to go to. So instead of set mission, we would be connecting to the server, pulling that data down, and then creating the mission modules from that in the future. The other thing we'll have very soon is multi-threading, so that we can run multiple things essentially at the same time. So that could be, we could have a thread for running the goto function, which will send the drone to the location, a thread that is checking for proximity to obstacles, a thread that is checking for input from us. For example, if we want to change the mission while it is running, so for example, add another location to go check out at the end or something like that, that is also going to be running in a new thread. So that is the quick intro to the guidance system. One thing I'll point out is how to create a new mission module. So to do that, we'll look at search pattern, which is a bit more complicated. But what we do here is we always inherit the waypoint class, because every mission module has at least one location associated with it. In the search pattern, we need to generate a list of waypoints that are in the particular pattern. So for example, a square spiral or a rectangle or some arbitrary polygon. The waypoints would do the zigzag pattern within that area. And for more complicated ones like this, we have to increment the waypoint, which when it is reached, so when the current waypoint in the list for this module is reached, we will either go to the next one in the list and continue the search pattern, or if we're done, we will say that that particular mission module is complete. So for creating new mission modules, always follow the pattern laid out by search pattern, or also by drop, which we inherit the waypoint class, potentially redefine the reached function to do different things like either go to the next location in the search pattern or drop the water bottle or things like that. But every mission module has to inherit the waypoint class. So thanks for watching, and please don't hesitate to ask me any questions about this. because it's very important that we all understand how this system works so that we can develop on it effectively.